Hi students, this is Mr. Yao. In this lesson, we are going to learn some new concepts, and that is called complex number. And this is the introduction to complex number. Before we get into complex number, of course, we need to understand the current number system that we have learned. Starting with natural number and integer. So natural number, we use letter n to represent, or it looks similar to n, and that would be the counting numbers. So naturally, when you start counting, you won't actually count 0 and then 1, 2, 3. It's when you actually start counting, like let's say you count how many students in the classroom, you start with 1, 2, 3, 4. And these are the natural numbers. Integer, that's natural number, and their negative counterparts and a 0. So positive number, negative number, and 0. For example, -3, -2, -1, 0, 1, 2, 3. Next, whole number, we have W. Whole number is actually a part of the integer. Whole number is just no negative numbers, counting number and 0. And then all of these are included in irrational number, which is already a way bigger number system compared to all the previous one we just talked about. Rational number is a number that can be expressed as a fraction. So terminating decimal, which means a decimal that stops. So like, for example, 1.2, let's say. And then repeating decimal is, say, like 1.3333, continue going, or 1.67676, continue going. A fraction, of course. Perfect square, let's say square root of 4, well, that is just 2, so that is also included. And all of these can be expressed as a fraction. So say 1.2, that is actually 12 over 10, which is 6 over 5. 1.3333, that is actually 4 thirds. And this one is a bit more complicated, but is actually 167 over 99. Oh, actually 166 over 99. Or in other words, it is 167 over 99. So repeating decimal could also be expressed as fractions. So anything that can be expressed as a fraction is a rational number. Then, of course, we have the counterpart, which is called irrational number. Irrational number is like non-terminating, non-repeating decimal. So let's say it's just randomly 1.2345, continue going. Even though there seems to be a pattern, it doesn't stop and there's no digit that's actually repeating. So that wouldn't be rational. So rational is not just about the pattern. It's about if it repeats. And in this case, even though you see a pattern, even if I do like 1.2468, and continue going, it's not repeating. There's no part that is repeating, so it's still irrational. Non-perfect square, like say square root of 2, square root of 3. These, if you type into the calculator, is going to give you a non-terminating, non-repeating decimal. And another big example is, say, pi. Okay, real number. The rational number and irrational number together is the real number. So all the numbers on the number line, fraction, decimal, everything's included. So for irrational number, for example, pi, you might be like, wait, but where is pi on the number line? Well, it's actually in between the 3.14 and the 3.15. It's just we can't exactly pinpoint, but it is on there. So that is real number. Now, let's see how they include with each other. So the smallest number range is, of course, a natural number. Again, that is just 1, 2, 3, 4. Follow these counting numbers. And then on top of that, for the whole number, we just include an extra 0. And then go to integer. That's where we start having, say, -3, -2, -1. And then, of course, it still includes the 0, the 1, 2, 3, 4. And then we have rational number. That's where we start having fractions. And here's the thing, even if it's like, say, -3, -3 technically is -3 over 1, so it still works. Or say 1.111111, continue, and that is actually 10/9. Or we can have like square root of 9, things like that. Irrational number, we can have pi, square root of 2, square root of 3. And you can see irrational number and rational number, they do not have any overlapping. A number can't be rational and irrational at the same time. But a rational number includes all of the integer, whole number, and natural number. Altogether, for rational number and irrational number together, they are called real number. And then today's lesson, we are learning about complex number that in fact include all the real number and some extra. So complex number is the biggest range of number that we will learn. We will expand our understanding about the numbers. Now let's move on. to go through some examples to identify. So I would ask you to pause here and try to identify these numbers as rational number and irrational number. Okay, hopefully you have finished, and let's check. Here they are, rational number and irrational number. Let's go through a few. So square root of 64 is just an 8, so that is for sure a rational number. And then negative square root of 100 is just negative 10, and that is just 11. Everything else, they are already fractions. This one is a repeating decimal. That's why it is a fraction. It can be expressed as a fraction, so it's a rational number. Pi is irrational. Square root of 75 is 5 square root of 3, and that square root of 3 is irrational already. And then square root of 32 is 4 square root of 2. That square root of 2 is also irrational. And then this number, you see, even though there's pattern 3, 4, and then 3, 4, 4, you got an extra 4, then 3, 4, 4, 4, you got an extra 4, even though you see pattern, it's not repeating. Like if you were saying, well, it is repeating 3, 4, and 3, 4, well, the next part needs to be 3, 4 again. So technically, it is not repeating, and that would be irrational. Let's do a few more. You can also pause here to identify these numbers to be rational or irrational. Now let's have a look. Fraction plus fraction, of course, is fraction. Square root of 6 times square root of 6 is a 6, so this is technically a 30. Fraction multiplied with fraction still works. And this square root of 2 times square root of 8 technically is a square root of 16, which is 4. So they are all rational number. Next, irrational number. Pi, if you divide it just by 2, it's still going to be irrational. Just all the digits are divided by 2, so it's still irrational. And then 1 minus pi is still irrational. Because square root of 2 is irrational, and then you have this negative 1/2, it's not going to cancel anything. Just going to subtract, so it's going to be like 1.414, something like that. And then this is just going to subtract a 0.5 from that number. Square root of 2 times 2/5, well, this is irrational. Multiply, they're still irrational. Square root of 6 and square root of 3, they're both irrational, and they won't just cancel each other out unless you're multiplying. Well, in this case, even if you multiply them, it's still going to be irrational, because square root of 6 times square root of 3 is just going to be a 3 square root of 2. The square root of 2 part is still irrational. So there you go. These are some quick examples for rational number and irrational number. Now let's understand about complex number. So complex number include some parts called imaginary number, which is the contrary of real number. So you see the name now, real and imaginary. Complex actually include all the real number and the imaginary number and the combo of both. In order to understand imaginary number, we are going to need to expand some understanding about square root. Imaginary unit is I. So we all know square root of 1 is 1. Square root of 4 is 2. But before, whenever we had to deal with, say, square root of -1 or square root of -4, our calculator would just give us an error message. However, that will change after this lesson. We can, in fact, deal with square root of -1 and square root of -4. Here is the definition that mathematicians have made up. That's why it's called imaginary number, because mathematicians like, how come square root of 1 has a number, square root of 4 has a number, but square root of -1 doesn't have a number? You know what? Let's make something up to define it. So they have defined square root of -1 to be called I, which is the imaginary unit. Definition: a complex number is a number that can be expressed in the form of a plus bi. A and b are both real numbers, so a is called the real part, and b is called the imaginary part, because b is a number in front of I. And since I is the imaginary unit, that is called the imaginary part. So for example, I can have 2 plus 3i. That is a complex number. So you see 2 is a real number, 3 is a real number, and that actually means any real number I want to express. So like say 2/5. It's still a complex number because that just means you're adding a 0, I. That's why you don't have the imaginary part. But the whole thing could still be written as a complex number. But because square root of -1 is an I, if we actually square both sides, so we got square root of both sides, that would get rid of the square root. So I squared is -1, and that is called the square root of a negative number property. Now let's see some examples and see how they work. Square root of 3. well, example 3, square root of -4, that is square root of -1 times 4. And here's the thing, typically when we have, like, say, square root of 4 times square root of 9, we can choose to multiply them together and get a square root of 36, and then simplify it to be a 6. Which means we can also go backward. We can choose to break numbers apart. So this is the same as a square root of -1 times a square root of 4. Square root of -1 is an I, square root of 4 is a 2, and we typically treat I like a variable, and there's no way we actually write like x2, so we typically put a 2 in the front, so it's 2I, just like 2x. Okay, next, square root of -48, which means whenever you see a negative sign, you just treat it as a -1. So technically this is square root of -1 times square root of 48. You all have just learned or just reviewed about how to simplify square root of 48. So that is going to be 2, 24, 2, 12, 2, 6, 2, 3. So this simplifies to be 4 square root 3. And then in the front, you still have the I. So it's I times that. And we typically keep the I in between the 4 and the square root of 3. But if you choose to write square root of 3I, that's okay. It's just you have to be very clear that this I is not under the square root. And to avoid that, that's why we put the I in front of the square root. But both ways, I'll take both. That is example 4. Moving on, example 5. So this negative sign is actually outside the root, so that does not change into an I, it just stays in the front. And then we have a square root of -1 times a square root of 9. So we have a -2 times I times square root of 9 is a 3. Altogether, -6I. Next, 20 times square root of -1 times square root of 10. Square root of 10 can't be simplified, and this just changed into an I, so it's 20I square root of 10. That's example 6. Moving on, example 7. This time, cube root. So we have a 6 in the front, and then there's a cube root of -1, because that's a negative sign, and then there's a cube root of 216. Let's be very, very clear. You can still take cube root, because cube root of -1 has a number. Cube root of -1 is just -1. That does not change into an I. I only happens when you take even roots. So like say square root of -1 is I, or fourth root of -1, it's I. So things like this. But when you have a cube root of -1, it does not change into an I. So there you go. Okay, let's move on. 6 times -1. Well, we haven't dealt with that. Cube root of 216 is a 6. So times 6, the whole thing is -36. That does not have an I. 8. -4 times cube root of -1 times cube root of 81. We have -4 times cube root of -1 is an I. Cube root of 81 is, cube root of -1 is not an I, it's a -1. Then cube root of 81 is a 3 cube root of 3. So altogether, -4 times -1 is a +4 times 3 is a 12 cube root of 3. So I throw in these two examples to just tell you only square root of -1 change into an I. Cube root does not change anything. Cube root of -1, you can't deal with it. That is -1. Moving on, example 9 and 10. -7, then is square root of -1 and square root of 243. The more you work with these, as soon as you see a negative sign under the root, you can already change it into an I. So it's -7 times I, and then 243 is a let's see, 3. Well, it's a 3 times 81. So it's actually going to be 9 square root of 3, because this is 3 to the 5th power. Okay, now I can put everything together. -7 times 9 is -63. And let's put the I before the square root, then square root of 3. Next, 9 times square root of -1 times square root of 75. So it's going to be 9 times I times 5 square root of 3. 5 times 9 is a 45. So it's 45I square root of 3. And that is example 10, and that is everything for this lesson. Thank you.